AB 2012 number 5. As we can see here, this was one of the tougher questions, especially for AB. When they took it, they only got a 2.87 average. Part A is asking us, is the bird gaining weight faster when it weighs 40 grams or 70 grams? And we have to explain our answer. Fortunately, we've got an equation right here that tells us the speed that B is changing. It's giving us the rate of change of B. And B is the weight, so this is the rate of change of weight, which is exactly what we're asking for. This 40 grams represents the weight of the bird, which is B. So if we put 40 in there, we end up with 100 minus 40 over 5, which ends up being 60 over 5, or 12. When the bird weighs 70 grams, we're going to go 100 minus 70 over 5, which ends up being 6. And the units here are grams over time, so per day. And just by looking at these numbers, when the bird weighs 40 grams, it's growing at a rate of 12 grams per day. And when it weighs 70 grams, it's growing at a rate of 6 grams per day. So it's growing faster at 40 grams. And we should include a sentence explaining that. Say something like, the bird is gaining weight faster when it weighs 40 grams because, just write something about how you figured that out. So maybe you end up with something like this. Since the rate of change of the weight is bigger at 40 degrees than the rate of change of the weight at 70 degrees, the bird gains weight at a faster rate at 40 grams. Done. This was worth 2 points. We're using dB over dt, so plug in those numbers in. Your second point came from your answer with a reason. That's it for part A. Part B is broken down into two pieces. First, it says find the second derivative in terms of B. So we look at that. We've already got the first derivative. Let's find the second derivative. Second derivative is going to be d2b over dt squared. That 1/5 is just a constant, so we can kind of ignore it, just leave it there. And then the derivative of 100 is 0. Derivative of negative b would be -1, but we have to say -1 dB dt. This is a related rate, or you could think of it as implicit differentiation. So we have to have that dB over dt. Fortunately, we know what dB over dt is. It was given to us right up here. So our final answer for second derivative would be 1/5 times -1 times whatever we had for dB over dt. We could clean that up a little bit. 1/5 times -1/5 is -1/25 times 100 minus b. I'll probably give you credit for either one of those two lines. Now we have to apply this. It says use the second derivative to explain why the graph of b cannot resemble the following graph. And that's a little tricky until you think about what second derivative actually tells you. Remember, we're only using values of b here from 20 to 100. No matter what value of b I put in between 20 and 100, 100 minus b is going to be positive or 0, but it's definitely not going to be negative. So we're going to have like -1 over 25 times a positive number, which means any of those places we should have concave up. Oh, I lie. Concave down. We know concave down because negative times a positive is a negative. Second derivative is negative, means concave down. It doesn't look like this is concave down the whole time, though. It starts off concave up, then becomes concave down. That's a problem. So you have to write something about that. And your sentence should say something about how no matter what value between 20 and 100 we plug in for b, we're going to get a concave down second derivative, but this graph is not concave down to 100. So maybe your explanation looks something like this. The graph of B is concave down from 20 to 100. Notice I didn't include 100 because that was kind of an iffy place. A portion of the given graph is concave up. Done. We found a contradiction. This graph can't possibly work. This question was worth 2 points. The first point came from what I have circled in green over here. Did you get your second derivative? Which means they're going to be checking for implicit differentiation. And you also got 1 point for a valid explanation. And that's it for part B. Part C is the big one. Part C tells us to use separation of variables to find B of t. We're starting with dB over dt, so we have to separate the variables. Put everything with a t on one side, everything with a b on the other side. So we end up with something like, we can also get rid of the fraction right now. We can get something like 5 dB equals 100 minus b times dt. But we need to get that 100 minus b back to the other side also. We have to get all the b's together. So we can have something like 5 over 100 minus b equals dt. Apologies, made a slight mistake. I forgot my dB. 5 over 100 minus b dB equals dt. Now we can integrate both sides. I don't like that 5 there, so I'm going to move it to the outside. And the right-hand side is pretty nice. Antiderivative of 1 dt is just t plus c. Antiderivative of 1 over 100 minus b, we have to use some u substitution. We could say u equals 100 minus b, du equals negative dB. Move the negative sign to the other side. So it looks like we're left with negative 1 over u du, which of course is negative natural log of absolute value of u. So we're going to write that back in with using b. We're going to change that natural log to 100 minus b equals t plus c. We know this bird starts at 20 grams and keeps gaining weight up to a maximum of 100 grams, which means we can get rid of that absolute value sign. Natural log of 100 minus b, and I'm also going to move that negative 5 over to the other side. Negative t over 5 plus c. We could say c over 5, but that c over 5 is just a constant. I'm going to leave that just plus c. Now it's time to use our initial condition to solve for c. We're using the initial condition b of 0 equals 20. So anywhere I see a b, I'm going to put 20. Anywhere I see a t, I'm going to put 0. Natural log of 100 minus 20 would be natural log of 80 equals 0 over 5 plus c. So c is natural log of 80. Now we've just gone through a lot of work to figure out that c. Now we got to put it all together. Using my natural log of 100 minus b equals negative t over 5 plus natural log of 80. It's time to get b by itself. So we want to solve for b of t. That means it's time to exponentiate both sides of the equal sign. That gives us 100 minus b equals e to the negative t over 5 plus natural log of 80, which really becomes 80 e to the negative t over 5, 100 minus b. Get that far and it's not so bad anymore. This was a lot of work. That's why it's worth 5 points. There's a lot going on here. So if we try to get b by itself now, we could say b equals 100 minus 80 e to the negative t over 5. And that's what we're looking for our final answer. Now let's talk about points. As we've talked about in class, you can get a lot of your points for these just by setting it up. They give you your first point if you just get your separation of variables. What that means is they can see that you put all the b's on one side, all the t's on the other side, like so. That gives you your first point. Second point, did you get the correct antiderivative here? And did you get the correct antiderivative here? Point 3, did you just remember to write plus c? That's all you had to do, write plus c. You get your third point, even if that other stuff is wrong. Then the next point, point number 4, comes from solving for c. That's a hard point to earn. You go through that and you get your fourth point. Then you have to work hard for your last point as well. That's where you go through and actually solve for b. Altogether, 5 points. And that's it for part D. That's it for AB 2012, number 5.